fluid coding and AI here. OpenAI's new Codex goal feature is small on the surface, but big in what it signals. Codex is moving from answer this next prompt toward own this bounded objective until the evidence says it is done. The pain this targets is familiar. You ask an agent to fix a bug, migrate a package, or refactor a component. It makes progress, then stops at a partial checkpoint and waits for you to type continue. That is fine for small chats. It is painful when the real unit of work is a verified fix, a completed migration, a reviewable pull request, or a clear blocker report. The official Codex changelog lists Codex CLI .1.28.20 on April 30, 2026. That release added persisted goal workflows, including app server APIs, model tools, runtime continuation, and terminal controls to create, pause, resume, and clear goals. The GitHub release repeats the same feature language and points to the related goal pull requests, so this is not just a docs-only hint. There is an important maturity caveat. The official /command docs call /goal experimental and say it only appears when the goals feature is enabled. The docs give two paths: open the experimental menu or set goals to true under the feature section in config.toml. In the 0.128.0 source registry, the same feature is marked under development and default disabled. The command surface is simple. /goal shows the current goal, /goal followed by an objective sets one, /goal pauses it, /goal resume starts it again, /goal clear removes it. That is the visible part. The deeper change is that Codex can keep the goal attached to the active thread while work continues. The first big idea is persistence. A developer can set an objective like finish the migration and keep test screen. After one turn, the agent should not need the human to restate what done means. The goal belongs to the active thread, so the runtime has a way to re-anchor the next action to the original objective instead of drifting through a long conversation. The second big idea is continuation with budget awareness. The checked-in continuation template tells Codex to continue working toward the active thread goal, choose the next concrete action, and avoid repeating completed work. It also includes time spent, tokens used, token budget, and tokens remaining. That matters because a useful loop needs a stop condition, not just more momentum. When the token budget is reached, the budget limit template tells Codex not to start new substantive work. Instead, it should wrap up with progress, remaining work, or blockers. That is a safer failure mode than an infinite loop. The agent may still be unfinished, but it should hand back a usable status report instead of burning through context with another speculative step. The most important part is not that Codex keeps going. A loop that keeps going can still be confidently wrong. The important part is the completion audit. Before marking a goal achieved, the template tells Codex to map every explicit requirement, file, command, test, gate, and deliverable to concrete evidence. That is the engineering move. Completion has to be proven against artifacts, not inferred from effort. The template is also explicit about proxy signals. Passing tests, complete manifests, successful verifiers, and substantial implementation effort are not proof by themselves. They only matter when they actually cover the goal. For developers, that is the right line. We do not need agents that sound finished. We need agents that can point to the evidence or admit the goal is not achieved yet. This feature will only be as useful as the goals you give it. A good goal sounds like acceptance criteria. Migrate this app from Pydantic version 1 to version 2, update tests, and leave a migration report. Another good one is find and fix the flaky checkout test, prove it with repeated runs, and document the root cause. The pattern is objective, boundary, required artifacts, verification commands, stop rule, and budget expectation. A bad goal is still bad automation. Make this better gives the loop too much room to wander. Improve the UI without a target state, test path, or acceptance check invites polished-looking drift. The safer habit is to write goals like serious task tickets. Name the artifact, name the boundary, name the proof. If there is a risk, include the stop condition before the agent starts spending the budget. The broader story is that Codex is becoming more than a one-turn terminal helper. OpenAI's April 2026 product update describes Codex moving into computer use, in-app browser work, image generation, plugins, memory, automations, and ongoing repeatable work. That does not prove/goal works for every repo. It does explain why a persisted objective loop is becoming product infrastructure, not just a convenience command. There are benchmark numbers in the research, but they need careful framing. OpenAI reports GPT 5.3 Codex at 77.3% on terminal, Bench 2.0, 64.7% on OS World, verified, and 56.8% on SWE, Bench Pro Public. Those are first-party model results from OpenAI, not an independent benchmark of the goal runtime loop. The honest takeaway is that model capability is rising, while goal-driven reliability still needs real workflow validation. Goal also does not remove the normal risk controls. OpenAI's docs still talk about approvals, sandbox settings, project instructions, memories, and human validation. That matters because longer-running autonomy can magnify both good setup and bad setup. A clear goal, a real verifier, conservative permissions, and reviewable diffs are what make this useful instead of just busy. My practical verdict/goal is worth watching and worth testing if you already use Codex for tasks with concrete acceptance criteria. Use it for migrations, flaky test investigations, guarded refactors, and documentation updates where the finish line is specific. Avoid it for vague improvement work. And when it says the goal is complete, review the evidence because autonomy moves the bottleneck from prompting to verification. If this helped you understand where Codex is going, like the video and subscribe to Fluid Coding and AI. I cover the developer tools, agent workflows, and practical AI systems that are changing how software gets built.